trigonometric identity here. It's a challenging problem. I've written down the Pythagorean identity for tangent squared x plus 1 equals secant squared x plus a couple different flavors of that one, which were used in the proof of the following identity. I wrote the left side of this thing as a difference of cubes, and that was the directions to use a difference of cubes. So tangent to the sixth of x is the same as the tangent squared cubed. Similarly for secant sixth of x, using the difference of cubes formula, it's tangent squared minus secant squared times the first term squared plus the product of the two binomial terms plus the second term squared. So that is, this right here is the difference of cubes. Tangent squared minus secant squared is a -1. So that's what I replaced here. I rewrote tangent fourth, tangent squared, secant fourth is secant times secant squared, and I still have this sitting out here. And now I'm going to replace tangent squared with secant squared -1, comes from right. And I'm going to replace this secant squared with tangent squared plus 1. Distribute. In other words, remove the parentheses here and remove the parentheses here. And look what we get. We get tangent squared, secant squared, tangent squared, secant squared, tangent squared, secant squared. There's 3 of them. And we have a secant squared minus tangent squared. But secant squared minus tangent squared is 1. So I didn't fit this up. I've got this -1 outside the parentheses. I've got 3 tangent squared, secant squared. Forgot the x there. And secant squared minus tangent squared is a 1. Distribute that -1. And what we did is transform the left side to look like this right side. So QED. There you go. Hope that helped.